So the next presentation has Mr. Angus Maxwell from Maxwell GeoSystems. He is owner of the company, and he has degrees in geology and PhD in rock mechanics, and was our project director for data systems for more or about 100 projects worldwide. Floor is yours, please.
Thank you very much. So what I'm going to talk about today is a review of the contract practices around risk management on ground engineering projects, specifically around about instrumentation and a sort of design feedback approach. So you can see this is the same project. I just showed the picture there with the instrumentation overview. So what sort of data are we talking about, and why do we need it? One of the big things I often talk about is the importance of context on the instrumentation that's being collected. And this may include the geospatial setting, it may include surrounding infrastructure, it may include the ground models and everything else. And it also includes the prediction, not just in terms of the prediction on what sort of ground movements we're going to expect, but also the predictions on what kind of ground are going to be expected by the machines and how those machines are going to behave in the ground. And then the information about what's actually happening on a site, the production, the progress, where is a tunnel relative to the monitoring points that you're putting in. That's also important to have in the system. And we need to have a feedback process whereby we're actually looking at in real time against the predictions that we've made and looking at the information that we are collecting. And of course, all the information about assurance, it's not just instrumentation, but also the environmental assurance that is done, and also some assurance on quality of the works and also safety of the works. So there's a lot of data being collected on projects, which currently is in a lot of silos. And I'd like to remind everybody of the Joint Code of Practice, which first came out in, I think, 2003, I'll probably be corrected, which talked about formalising active risk management and ensuring that we had systems in place to keep looking at risks. And also it talks about quantifying uncertainty and constant reviews. So it's really important that data is central to that process. And it also talks about the importance of independence and full transparency. So, problems with data. Now, I'm sure everybody in the room will recognise a lot of these problems. We've all experienced them. I started this company because I was experiencing these exact same problems. You're getting data that's only partially recorded. You're getting multiple versions of the same fact, so which one is true? You're getting data being hidden or not shared. We've got a failure to agree data in a timely manner, meaning you can't progress the works effectively. We've got data that's unusable when you come to use it either at the end of the job or any time during the job. We've got data that's not handed over at the end of a job, so you're missing that retained value in data to be able to plan the next job. There's inertia. People not wanting to change the way they've done things, and that's stopping things from evolving. And then uncertainty not being recognised. I have a law. The confidence in the interpretation is inversely proportional to the thickness of the pen. It comes from geophysics. So you be a big, thick pen to make your interpretation. Suddenly, that's the truth. It obliterates the data. So what are the consequences? Well, there's increased likelihood of unanticipated ground behaviour and asset damage. Okay, because you're not getting this feedback process happening. You end up with conservative design because maybe you're not seeing all the data that you should be seeing in order to design the work. So you build in conservatism. You've got delays due to dispute, rework, or additional investigation because you're not getting all the information that you could have. Higher insurance premiums. Higher risk equals higher insurance. More data can lower insurance premiums. Weak factual basis for claims. Clearly, if we're looking at on both sides, from the contractor or the owner, the necessity of having good data means that the claims can be either not started or they can be evolved. And then the loss of organisational learning. If you don't have that data to carry with you, companies, people will come and go, but their data remains the same. So that's the real power in a company, is keeping hold of your data and using it to your advantage. Why do these problems happen? I mean, we all feel this. Contractual arrangements often result in a misaligned motive. Okay, people may not necessarily want to share the data because of the way the contracts are arranged. You end up with organisations ending up duplicating the recording of data, which is really quite pointless. You have a lack of upfront and back-end investment. People aren't prepared to invest capital expenditure to put in place systems, so they end up going along with what they've always done. You have wrong investment. I see so many times people complaining that we're reinventing the wheel on jobs. It's already been done. Why don't we do what we did? You can't innovate on every single job. You need to use your innovation at some stage. We've got a failure of oversight, lack of transparency on jobs. We have inertia and siloed behaviour. Everyone knows that. I can't get to the information I need because so-and-so's got it. Slow setup. If you're trying to invent something from scratch, it's going to take a long time. So often things are slow. Lack of investment training, and then often no dedicated data role in a project. A lot of investment in BIM, but not on the kind of data that we're talking about here. So one of the things I wanted to concentrate on was the effect of the contract model on this. So going back 30 years, here's a project I was involved in Hong Kong. It was a deep tunnel, a little bit like the last example you just saw, going underneath the harbour in Hong Kong. IC contract, owner, engineer, contractor, fast track, political pressure, all the risk was put on the contractor, highly confrontational. In the end, there was an impossibility arbitration. And it came about because of tunnels were deep, a lot of water, very difficult to deal with the water. And in the end, lawyers all over the place on this job, very high sensitivity. But one problem, 2 completely different sets of data collected by the 2 parties. And ultimately, they had to establish what the facts were. And one of the reasons I started this company was because of a thing called the Tunnel Data Management System, which I created back in 1997. And this had all the data in one location, all internally audited, correct, single source of truth, up-to-date, accessible. And in the end, the arbitrator really relied on this data to deal with the case as being the factual basis of the job. So, new delivery methods. So we've got collaborative contracts now. We've got alliancing. We've got target cost contracts. We've got PPPs. These are all based on this sort of concept of pain share, gain share. And because everybody's got their, one hat for the project, very, very successful. Okay, problems are expected to happen and they're engineered out. Uncertainty was recognised and managed. Observational engineering was welcomed. Systems were invested in. They weren't afraid of capital expenditure. The only reasons these didn't last was because when pain happened, it was too much for a lot of the contractors to bear. We know quite a few projects where it was an issue. So in a lot of places they moved to design and construct, or progressive design, or what's called ECI in the UK. Examples here are KVMRT, the Hong Kong Drainage Tunnels, Mobile Metro, etc. A lot of these cases, risk was pushed to the contractor, and as a result, the owners ended up with a lot of reduced control of the data. It was reliant on the contractor to provide the data. Alternatives were put in place, and the contractors pushed those alternatives forward, in some cases, very successfully. But in these things, a large amount of claims, and ultimately it came down to which party had the best data, still 2 separate sets of data. In this case, on a number of locations, particularly Hong Kong, they put in place what's called a TDMS. This is the follow-on from the one I created all those years ago. Very successful, but the problem here was one of perception. This is the owner's system in a contractor's contract. Okay, so there's not really the ease, really, in the contractor to be able to provide all that data to the owner. And here's a number of them that were done in Hong Kong, lots and lots, over 20. So it comes to 2008, and after that joint code of practice put in, there was an approach to how do I deal with the risk. So I'm just giving you 2 examples here. The LTA in Singapore decided on full control. Monitoring would be done by the owner. A system was developed and run by the owner, and that system was called TENS. Unfortunately, it did not include the contractor's own data, and there was no access for the data to extract the data to do their own thing. So it's very much they were just sort of a person to run the system and not be engaged in the data itself. Alternatively, in Hong Kong, the MTRC ran a thing called the IMC, Independent Monitoring Consultant. And what this did was it allowed the contractor to engage the monitoring themselves. The independent consultant did 15% of the monitoring on a checking basis and provided the system for the whole project. This allowed the consultant to do an independent review on the data and give feedback to the owner as to whether things were on track or whatever. This independent role was very, very favourable to the insurers and actually enabled the MTR to negotiate a lower insurance rate on the project. There was, of course, the higher cost of the check monitoring. So it was a give and take, really, in terms of the overall project cost. But in terms of reducing risk, this was a clear benefit. Now, going into 2011 to 2020, there was then a move to more openness, learning to share. Singapore Power created the idea of information partnering. Just like any other partnering, we make a partnering charter, we put down our intentions in that charter, and then we agree at an executive level. And all 7 parties, all 6 contractors and the owner, all signed up to this charter and shared the cost. This was excellent. It accelerated the project. We had a 72-month contract originally for this system. It was only needed for 55 months. I've not been on another job that ran as smoothly as this, where everybody engaged together to share the data for the benefit of the project. And some examples of how data was used and combined together into very early digital twins, dashboards for TBM control, and even here, being able to stop a problem. You can see here there's a sand layer at the bottom of this diaphragm wall. It was identified by the client, shared, and work was done collaboratively to fix it. So, coming into the present day, we're moving into a time when there's much more collaboration going on. It's all good to hear, where owners are realising that actually they can take a little bit more control. I hear back from contractors now that they say, well, I'm happy with this. Why would I want to have a computing project when I've got a tunnel construction project? I'm happy for the owner to run these systems, and I'll contribute. So on these 2 projects in Singapore here, DTSS2 and Changi, the owner provided the system, and this system was run for the benefit of over 30 contractors on this project, 100 kilometres of tunnels. This demonstrated a very important fact of this, is that this was right in the middle of COVID. And for a very long period of time, none of the people on this project, all 30 contractors, over 1,000 users, none of them could go to the office. So this system became their virtual office for all of this data. And it covered every bit of data. It covered over 20 TBMs. It covered about 70 pipe jacks, 4 shaft sinking machines, 400 cameras. Everything was done through one place. And the fact that that was available, it enabled people to carry on the projects. And I just heard about that TBM. One of the TBMs that refurbished on the last project was on this job, I believe. Yep. Nice to see it again. So it's the same people who worked on this job now working on the Changi job. So we did the Changi airport tunnels together in the same model, and proved very, very beneficial, I think, for everybody. So, in conclusion, the benefits of greater control by the owner are there. You can lower risk on projects. Sharing data is the future. It's the way to achieve transparency. It's a way to achieve confidence. And I have seen over 30 years now that as soon as you can make people more confident, you can make projects go faster and safer. And there's now 0 implementation risk because it's been done. People didn't want to do this in the past because they thought, oh, I don't want a problematic IT job in my hand. It's now been done. It's been put on several projects around the world, so it's easy. The insurers, ask them. This reduces risk for them. They are willing to come with you to do this process. And ultimately, everyone says, oh, well, isn't that going to cost me money? The cost of doing one system on a project is a lot less than putting in 20 systems, and the time for people to open one system, grab the data, go to another system, grab the data, spend time putting them together, data wrangling, everything else. Okay? It's 2026 now. We don't need to do that anymore. So on that note, thank you very much for your time, and I think I've got 15 seconds left.
Thank you for keeping time. So we have time for any question, if there is, from the audience or from co-chairs.
Angus, do you think clients should be mandated to install instrumentation on buildings for the whole life cycle, not just for construction, for the benefit of monitoring the ground? Do you think all major infrastructure projects should have a nervous system built in to monitor the whole life?
You mean the life of the asset of the building, or you mean the buildings that have been monitored, or the actual tunnels?
Yeah. No, yeah. It could be for everything, but let's say tunnels.
Well, I'd say for the tunnels, I think a lot of people are doing that now. I mean, on the DTSS project we just saw there is 26 kilometres of optic fibre, 4 strands going down the tunnels, and then monitoring the behaviour of the tunnels during the various full and half full and whatever, because they're pressure tunnels. And they've got a quite complex lining. It's a multi-part lining, and they want to observe how it's performing. So I think there's definitely benefit for putting in place long-term monitoring into the tunnels to see how they perform into their life cycle. Because obviously a lot of money has been spent on maintenance, and we've seen that graph of time versus maintenance. If you can get information to tell you what the time maintenance curve is, you can plan it a lot better.
The only reason why I asked the question is that clients could contribute to reducing factors of safety based on real-time data over 20, 30 years about the structural behaviour of buildings.
I agree. I think there's a great sense in people sharing information that may be of value to others. I mean, I was just talking with somebody earlier that I worked on a project where, due to an alternative, a contractor was able to break rings on purpose because they were sacrificial and they were going to be taken out. So we put in some monitoring, actually created an I segment with an on button. So you could actually see this segment heating up as it went into the tunnel. And they broke them, or tried to break them on purpose, to see the benefits of fibre versus rebar. And the results were fantastic. We did publish them, but the data is still there. And I think that data would be very, very good to give to the community so that they can look at it and say, okay, what does this mean for me? So I agree with you, definitely.
Okay, thank you.
Thank you.